Hello everybody. I had to share some information I found again. Assessing the direct occupational and health and public health impacts of solar radiation management with stratospheric aerosols. Alright. Geoengineering is a deliberate, large-scale manipulation of environmental process that affects the Earth's climate. In an attempt to counteract the effects of climate change, injecting sulfate aerosol precursors and design nanoparticles into the stratospheric i.e. solar radiation management, which is SRM, has been suggested as one approach to geoengineering. Although much is being done to unravel the scientific and technical challenges around geoengineering, there have been few efforts to characterize the potential human health impacts of geoengineering, particularly with regarding to SRM, solar radiation management, approaches involving stratospheric aerosols. This paper explores this information gap. Using available evidence, we describe the potential direct occupational and public health impacts of exposures to aerosol likely to be used for SRM, including environmental sulfates, black carbon, metallic aluminum, and aluminum oxide aerosols. We speculate on possible health impacts of exposure to one promising SRM material, barium titanate, and using knowledge of similar nanomaterials, we also explore current regulatory efforts to minimize exposure to these toxins. Our analysts suggest that adverse public health impacts may reasonably be exposed from SRM via deployment of stratospheric aerosols. Little is known about the toxicity of some likely candidate aerosols, and there is no consequence regarding acceptable levels for public exposure to these materials. There's also little infrastructure in place to evaluate potential public health impacts in the event that stratospheric aerosols are deployed for solar radiation management. We offer several recommendations intended to help characterize the potential occupation and public health impacts of SRM, solar radiation management, and suggest that a comprehensive risk assessment effort is needed before this approach to geoengineering receives further consideration. Alright, so this is called Assessing the Direct Occupational and Public Health Impact of Solar Radiation Management with Stratospheric Aerosols. Okay. Now it gives you this picture, Earth's radiation budget. Not sure how real it is, but it's from NASA. So, alright, then it gives you this one. Alright, and this one says, like the space mirrors. Alright, mirrors reflect sunlight from Earth's orbit. A mirror, wouldn't that magnify it coming back at us? Just saying. And then the spraying, the cloud seeding, the foresting, planting of additional trees to extract CO2 from air, artificial trees, trees designed to extract and store CO2 from the air, reflective crops, plants with reflective leaves, okay, burning and bristles of carbonaceous agriculture waste, ocean fertilization, addition of iron filling to promote growth of CO2 extracting. See, extracting. For some reason, they are extracting all this. I'm not sure why. See, CO2 extraction again. Okay, so due to atmospheric circulation and gravitational deposition, large-scale population exposures to atomospherically injected SRM material will almost certainly occur after their deployment. Population exposures could also occur through ingestion of food and water contaminated with deposited particles, as well as exposures could also occur through transdermally. Unlike occupational exposures, there has been virtually no research done to estimate ground-level personal exposures to SRM materials. Through the U.S. Environmental Protection Agency, which is called EPA, does provide guidance on methods for evaluating environmental exposures to several possible SRM material. Stratospheric injection of sulfur dioxide and black carbon has already been modeled to analyze potential deposition of sulfate and soot. One model estimated that with 1 tg of black carbon infused in the stratosphere annually, after 10 years of geoengineering, the globally averaged mass burden would be approximately 8 by 10 minus 6 kgm minus 2. The intentional addition of black carbon to the atmosphere will exacerbate adverse health effects already resulting from unintentional release at ground level. In the year 2000, the global emission of black carbon was estimated at 7.6 tg, and the globally average mass burden of black carbon was roughly 1.5 times 10 kgm. No models appear to have estimated the potential global burden of environmental alumina, or barium titanate that might result from SRM, solar radiation management. In contrast to occupational exposures, population exposures to SRM, solar radiation management, materials will be continuous and prolonged over months to years, but will likely be orders of magnitude lower than those experienced occupationally. Thus, the health effects will be primarily chronic in nature. The use of PPE to reduce personal exposures to deposited SRM material is not feasible on a population scale. Alright, so then we got this one. Alright. Human health effects of potential solar radiation management aerosols. Alright. Go up high enough, or maybe you can pause on it and see it all right there. I mean, we got the respiratory, cardiovascular, the GI, the hematologic. I mean, that's everything. The aluminum compounds, barium, black carbon, hydrogen sulfide, sulfur dioxide, sulfuric acid. I mean, that's not good. I got all this I could read too, which is the inhalational studies with sulfuric acid aerosol suggest that it has a local irritant effect and no systematic effects. Squamous cell metaplasia in the laryngeal, oh my goodness, these are some words, epithelium has been observed in animal studies at exposures as low as 0.3 mg over m3, with more severe metaplasia following exposures of 1.38 mg over m. Epidemiological studies suggest a relationship between exposure to mists containing sulfuric acid and an increased incidence of laryngeal cancer. And the International Agency for Research on Cancer has concluded that occupational exposure to strong inorganic mist containing sulfuric acid is carcinogenic for humans. In humans, and in particular asthmatics, increase in specific airways resonance or decreases in forced expiratory volume or forced expiratory flow for the primary response following acute exposure to sulfur dioxide. Cough, irritation, increased salivation, and erythema of the trachea and main bronchi occurred following controlled exposures to 8 ppm for 20 minutes. Exposures to higher levels can produce a burning sensation in the nose and throat, dyspnea, and severe airways obstruction that may only particularly reverse over time. Exposures to even higher levels can result in reactive airway dysfunction syndrome, which involves bronchial. I'm not good at pronouncing words, guys. I'm not good at all. I even read through all this. Epithelial damage and increased sensitization, and nonspecific hypersensitivity to other irritant stimuli. Deaths can occur following exposures. Single exposures to hydrogen sulfide can cause health effects in many systems. Hydrogen sulfide has an odor threshold of 0.01, and humans become insensitive to its odor at concentrations of 140. Respiratory symptoms in asthmatic individuals appear at about 2.8 milligram over mg over m3, but respiratory distress does not seem to occur. Eye irritation can occur at 5 to 29 mg over m3, and metallic abnormalities may occur at 7 mg over m3. Neurological symptoms such as fatigue, loss of appetite, headache, irritability, poor memory, and dizziness may result from exposure 28 mg over m3, with deaths occurring at 700 mg over m3. And this here, hydrogen sulfide, if you look it up, we have the CO2 carbon things we have to put on our walls, which you want it down low, which this is the next thing that can harm you, and you cannot see it, or it's very odorless, I guess, and I looked into that. Limited information is available on the kinetics of carbonyl sulfate, which likely metabolizes to carbon dioxide and hydrogen sulfide. Acute exposures result in symptoms similar to those of hydrogen sulfide, but with less local irritation of olfactory warning. Sublethal exposure can result in profuse salivation, headache, vertigo, amnesia, confusion, nausea, vomiting, diarrhea, cardiac arrhythmia, weakness, muscle cramps, and unconsciousness. Concentrations as 1,000 ppm can cause sudden collapse, convulsions, and death from respiratory paralysis. Alright guys, this is pretty bad. That's why I had to read it to you. Respiratory effects in black carbon workers include cough, sputum production, bronchitis, pneumocystis, and decrement in lung function, as well as tiredness, chest pain, headache, respiratory irritation. Black carbon may cause discoloration of eyelids and conjunctive, and is possibly carcinogenic to humans. Group 2b. There is inadequate evidence of carcinogenicity in humans, but significant evidence in experimental animals. Aluminum is never found free in nature, and instead forms metal compounds, complexes, or chelates, including aluminum oxide. Aluminum and aluminum oxide do not appear to differ in toxicity. Wheezing, dyspnea, and impaired lung function, as well as pulmonary fibrosis, have been noted in workers exposed to fine aluminum dust. Dilation and hypertrophy of the right side of the heart have been seen in workers exposed to aluminum powder to have decreased red blood cells, hemoglobin, and finger clubbing. Helper T lymphocyte alveolus and blastic transformations of perpetual blood lymphocytes in the presence of soluble aluminum compounds in vitro were found in an individual exposed to aluminum dust. There is limited evidence of carcinogenicity among workers. The few existing studies have been confounded by concurrent exposures to known carcinogens like tobacco smoke. Barium titanate is a complex salt containing two metals, which complicates modeling of its. Sorry, my hand is starting to shake. Toxicological properties. In general, exposures to barium salts are associated with respiratory, cardiovascular, gastrointestinal, musculoskeletal, metabolic, neurological effects. Barium salts also have a local effect on skin surfaces and would not likely be absorbed systematically to any great extent. Though this might be true of barium salt nanoparticles, barium titanate could also behave like a titanium salt in interactions with the human body. in which case the resulting health effects are essentially unknown. Only 2 titanium-containing compounds are indexed by the U.S. Agency for Toxic Substance and Disease Registry, ATSDR, or converted by U.S. exposure limits. It is possible that barium titanate might act both as a salt of barium and titanium, or as neither. The toxicological properties of nanoparticles are influenced by factors such as particle size, surface area, chemistry, or reactivity, solubility, and shape. Alright, there's also all this, but then I was just going to show you guys this thing too, which is I don't know if you can see it very well. There we go. Safety and Health Administration, U.S. National Institute for Occupational Safety and Health, the American Conference of Governmental Industrial Hygienists. Alright, sulfuric acid, sulfur dioxide, hydrogen sulfide, carbon, aluminum. Alright, that's pretty bad. Gives a little thing down there too. I just had to share this with you guys. For public exposures was likely to be widespread following SRM efforts. The EPA, European Environmental Agency, EEA, and World Health Organization safety specify regulatory standards for ambient air quality. Importantly, Table 3 shows a very small sampling of air quality standards in the use around the world that relate to the potential SRM materials. Okay, which is this one. Right here. That's the air quality, okay? So, I mean, these are like hours. 1 year, 24 hours. Nanoparticles. I mean... It's yeah. Conclusion. Although there is very little agreement in the scientific community on the approach to SRM-related technologies, SRM has been identified as a potentially technically feasible and possibly cost-effective method of geoengineering to reduce or reverse anthropologically driven climate change. But even as much as being done to unravel the scientific and technical challenges around geoengineering, there is substantial evidence that a host of adverse human health effects will directly result from climate change. Very little has been done to describe the potential human health impacts of this emerging disruptive technology. We have described the potential occupational and public health impacts of inadvertent exposure to potential SRM materials, solar radiation management, and have also speculated on the possible health impacts of exposure to barium titanate using knowledge of similar nanoparticles. Based on our analysis, we submit that the current knowledge gaps do not justify deployment of the SRM in the short term. We therefore recommend further research, a more inclusive analysis of costs and benefits, as well as the globalization and harmonization of regulatory standards that will limit the negative human health impact of SRM. Only following a comprehensive risk assessment that addresses each of these issues can potential benefits of this geoengineering approach be weighed against the potential public burdens created by this technology. Okay, so... oh yeah, that's what those mean, but... alright, and then I copied this. So it says they did the study shows there's a difference in the levels of performances by this N95 and the P100 respirators. If you're going to get a mask, this is the P100 followed by these ones are the best ones for you. Why would you come in here and jump on the bed like that? Thank you. Goodness. Kids, huh? Alright, and this one, experimental evaluation of personal protection devices against graphene nanoparticles, fibrous filter media mask, protective clothing, and gloves. Alright. In this study, different conventional personal protection devices, fibrous filters, cartridges for respirators, protective clothing, and gloves, well qualified for micron particles, were tested with graphenite nanoparticles ranging from 10 to 100 nm electrical mobility diameter. For this purpose, 2 specific test benches were designed, one for filter-based devices which are tested under a controlled airflow and other for gloves and protective clothing based on the through diffusion method. The penetration versus particle size shows for most test filters media the behavior predicted by the theoretical Brownian capture. Penetration decreases when particle diameter diameter decreases. No thermal rebound was detected until 10 nm for graphenite nanoparticles. Protective clothes were tested by 2 methods and same trends were obtained. Non-woven fabrics, such as airtight materials, are much more effective against nanoparticles than cotton and paper. Gloves tested through diffusion technique in static conditions seem to effectively protect against graphite nanoparticles in spite of their important porosity. Alright, everybody. I had to share that. I had to share that. It's just crazy. Thank you for listening. I know it's a long one. Have a great day.